Okay, the recording just cut off, so we're just gonna continue where we left off. And I think you're on number B. Why is this on an angle? Okay, there we go. So arc sine is the opposite of sine, so that's how we cross it out. So angle B is equal to arc sine 3 divided by 5. Okay. And then you just write that out into your calculator, arc sine fraction 3 over 5, and you should get angle B to be equal to 37 degrees. Okay, example 4, let's check this one out here. So it says, determine the length of side A to the nearest tenth of a centimeter. So here, for example, it doesn't tell you if you're going to use cos or sine. We're in the cos or sine section, or even, well, tan, but we know we already did unit tan, but you could be thinking of tan as well. So to start off with, you're going to always label the triangle, step 1, based off the reference angle. So if they gave us 50 degrees, so we're going to use 50 degrees. This will be the opposite. Maybe you should always label the hypotenuse first. So across from the right angle is the hypotenuse. Therefore, this has to be the adjacent. Okay, step 2. Right here it says, decide which formula to use, sine, cos, or tan. You must know 2 of 3 measurements. So we're talking about the sides and the angle. So let's see what we have. So given, we have the angle. They gave us angle. So I'll even write a little section here saying given, we got angle. What else do we have? We have the hypotenuse. And yeah, that's it. And what are we looking for, right? So this is a given. And we're looking for, so put down looking, side A, right? So side A, again, remember, if this is capital letter angle A, you know this is going to be side A. So this side is the adjacent we're looking for. Okay. So now we're looking for the adjacent, and we have the hypotenuse. So what trig function talks about hypotenuse and adjacent? Remember, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse, and finally tan is opposite over adjacent. So here you're gonna have to use the cos law, right? So adjacent over hypotenuse, adjacent hypotenuse. So I'm gonna write that out. Cos, we'll just use A in this case, or sorry, C because we're using angle C. Cos C is equal to adjacent over hypotenuse. Okay. So we figured out step 2, which one we're supposed to use. And now we're going to fill in the formula for all our known values. We have the 2, we have the angle, and we have the hypotenuse. So angle is 50 degrees. Adjacent is unknown. So I'm just going to leave it as A. And we have the hypotenuse, which is 5.2. Okay. And there we go. And now all you need to do is rearrange this. So we want to isolate for the A. So we have to do the opposite, dividing by 5.2, which is multiplying by 5.2. So multiply 5.2 here, meaning you have to multiply by 5.2 here, right? And then I'll rewrite that. So it's going to be 5.2 multiplied by cos 50 degrees is equal to A, right? And then finally, if you type that into your calculator, you'll get A is equal to 3.3 centimeters. Okay. And the last thing you could do here is you could just think about if this makes sense. 3.3 centimeters is smaller than 5.2. Remember, the hypotenuse has to always be the biggest side. So in that way, it kind of makes sense. Gives you a little clue. So for some reason you got like 7 for the adjacent side, you know you did something wrong because adjacent can't be bigger than hypotenuse, right? Okay, so example 5, same sort of thing here. We'll start the same way. So determine the length of side F to the nearest tenth of a centimeter. So let's label this. So across from F is hypotenuse, right? Across from the right angle. Right next to the, oh sorry, we're going to be using a reference angle. So across from the reference angle is the opposite. And right next to the reference angle is going to be the adjacent. We're using this because this is the angle that we're given, right? And you know that side F is going to be across from angle F. So this is F, right? This is side D, and this is side E. Okay. So now what you're going to do is simply say, okay, I'm given, what values am I given? I'm given the opposite. We have the opposite. I'm given the angle. And then we're looking for the hypotenuse. So now you got to say, like, okay, what trig function involves opposite and the hypotenuse? And then you're going to go through SOHCAHTOA. So sine is opposite over hypotenuse, opposite over hypotenuse. There we go. So it is going to be sine. So sine theta, now again, I'll do these steps again, is equal to opposite over hypotenuse, right? And then finally, plug in the values. Theta, in this case, the angle is going to be 55 degrees. And notice sometimes I use theta, sometimes I write the angle, but it's like this. Opposite is 6.8 centimeters. And the adjacent, the hypotenuse is unknown. Okay, leave it as hypotenuse, or I could leave it as F. Okay, we'll see like that. So, and then you're gonna rearrange it. So to get the hypotenuse, what you can do is you can multiply. So this is over an invisible one, remember? Hypotenuse times sine 55. Oops. Hypotenuse times sine 55 degrees is equal to 1 times 6.8, so just 6.8. Right? And the last thing, to get rid of the sine 55 from the hypotenuse, you can divide this side by sine 55 and this side by sine 55. So maybe I'll write it over here. So let's divide this by sine 55 to show you. This crosses out, and this divided by sine 55 degrees. Okay, so rewriting that out a little bit nicer. Hypotenuse, and maybe I should have wrote down F because that's what telling us to find F, but 6.8 centimeters divided by hypotenuse. Oops, not divided by hypotenuse, divided by sine 55. Right, and then this is going to equal, on your calculator, if you do that out, and I'll change hypotenuse to F because that's what they want, 8.3 centimeters. Okay, so 8.3 just from dividing 6.8 divided by sine 55 on your calculator. Okay, good. Okay, last page here. So again, the steps are all here. If you want to reread them, label the triangles, decide if you're using sine, cos, or tan, fill in the known values and what you're looking for, and then then you're going to either do, if you're finding the side, you're going to be using sine, cos, or tan. If you're finding an angle, you'd be using the arc sine or arc cos or arc tan. So that's all the steps. Okay, so again, we'll just start with the steps. Let's label the triangle in this case. So it says determine the measure of angle G and to the nearest degree or tenth of a degree. So angle G, where is angle G? It's right here, right? So this is a reference angle in this case, and we're looking for an angle. So since we're looking for the angle, we know at some point we're going to use either arc sine, arc cos, or arc tan. Okay. So let's fill out the hypotenuse tan and hypotenuse opposite and adjacent. So across from the angle, hypotenuse. Across from the reference angle is the opposite, and right next to the reference angle is adjacent. Okay, we did that. And now we can write down given. What values are we given? We're given the hypotenuse. We're also given the adjacent. And we're looking for the angle. Okay, so I'll put a question mark here. Okay, so that's how we set it up. So now you're going to think about step 2. What are we using? Sine, cos, or tan. So what trig function uses hypotenuse and adjacent? So sine is opposite over hypotenuse, so no, we don't have the opposite. Cos is adjacent over hypotenuse. Oh, adjacent hypotenuse, yeah. So we're going to be using cos. So that's pretty much how you figure it out. And you don't have to worry about tan because we figured out cos is what you need. So cos theta, and I'll use the actual values here. So cos instead of theta, put angle G, right? So cos angle G is equal to hypotenuse, sorry, adjacent is cos, adjacent over hypotenuse. I fill in the values, so cos, and I'll forget the angle sign here, just put G. Cos G is equal to 3 over 7, right? And now, to get rid of the cos from the G, we're trying to isolate G because G is the angle. We need to do the opposite of this cos function, which is arc tan. So cos -1, these cross out, and then you're going to do cos -1 on this side, right? So I'll rewrite that. So G is equal to cos, arc cos, bracket 3 over 7. And then you're just going to type this into your calculator. And in your calculator, you should get G is equal to 64.6231. And then we need to round it to the nearest tenth. Remember, the 10th spot is the second, the number right after the decimal. So G is equal to 64. In this case, it rounds down because we're looking at the number right, the 100th spot, and it's less than 5. So 64.6 degrees. Okay, sweet. Last question. Same sort of idea, but this is a word problem. So the only extra step you need to do with the word problems is you're going to have to draw it out. So whenever you see a word problem, draw out the triangle. Okay, so let's read this. A water bomber is flying at an altitude of 5,500 feet. The plane's radar show that it is 9,000 feet from the target site in the forest. So you got a plane flying. So it says altitude. Altitude means how high it is in the sky. So yeah. What is the angle of elevation? So remember, the angle of elevation is going up from the horizontal. So review that from the definitions if you forgot that. What is the angle of elevation of the plane measured from the target site to the nearest degree? Okay. So let's draw that out. So we know that there's like a little plane. I'm not even gonna draw the plane. This is the plane, the dot. Okay. So its altitude is 5,500. So how high it is from the sky. So we know we could draw a line here. I can label this 5,500. And you notice that you're always going to be drawing triangles in the trig section. So you notice whatever you draw is going to be like a triangle. So, and this point, at some point further from it is the forest fire. So this is a plane in the sky. Say the forest fire is over here. And how far are they away from each other? 9,000 feet. So, and you may want to use a ruler, otherwise you get a wobbly triangle like that. 9,000 feet. Okay, there we go. And then obviously we could just connect this because we're creating a triangle. So we have this value known, and they're looking for the angle of elevation. Remember elevation I just mentioned? This is the horizontal line. The elevation is the increase, so going above the horizontal, right? So this is going to be the angle of elevation, right? So we'll just call this, I don't know, we'll just call it theta for now, okay? So there we go. So from this reference angle, now we can do just how we false solve like all these other triangles. So what is the opposite from this reference angle? This is the opposite. This is 90 degrees, so this has to be the hypotenuse, and this has to be adjacent. Okay. What are we given? So given values, we're given the opposite, we're given the hypotenuse, and we're looking for theta, right? So yeah, so what trig function involves opposite and hypotenuse? So sine is opposite over hypotenuse, and cos, well, we can just stop there because now we know it's sine. And sine is opposite over hypotenuse. So sine theta is equal to opposite over hypotenuse. Opposite is going to be 5,500, so I'll just fill in the values now. The hypotenuse is the 9,000 feet, right? And we want to figure out the angle. So whenever we're going to do angles, remember, you're always going to have to do arc function. So to get rid of the sine that's attached to the angle. So you're going to do arc sine here and arc sine here, right? So these will cross out. And so you're left with theta equals arc sine 5,500 divided by 9,000 feet. Okay, so you do that on your calculator, and you should get theta is equal to 38 degrees. And on word problems, I think you're supposed to always write a word answer as well as sentence. So the angle of elevation is 38 degrees. Okay, there we go. So yeah, that's it for notes day 2, and yeah, I'll be talking to you soon. All right, bye.